Welcome to Technology Comparisons Crashcasts. I'm your host, Sheila, and today we're diving into an exciting topic, Prometheus versus Grafana. Joining me is our expert, Victor. Victor, are you ready to unravel this comparison for our listeners?
Absolutely, Sheila. I'm excited to break down these two powerful tools in the world of monitoring and observability.
Great. Let's start by outlining what we'll cover today. We'll begin with a brief history of both tools, then compare their core features, discuss their strengths and weaknesses, and explore real-world applications. We'll also touch on common misconceptions and best practices. But before we dive in, let's kick things off with a quiz question for our listeners. Victor, are you ready?
I'm all ears, Sheila.
All right, listeners, here's your quiz question. Which of these tools, Prometheus or Grafana, is primarily a data visualization platform, and which one is primarily a monitoring system and time series database? Think about it, and we'll reveal the answer at the end of the episode. Victor, any thoughts on this question without giving away the answer?
That's an excellent question, Sheila. It really gets to the heart of the difference between these two tools. I think many people who are new to the field might confuse their primary functions, so this question will definitely make our listeners think.
Indeed. Now let's start with the basics. Victor, can you give us a brief history of Prometheus and Grafana? When were they created, and why?
Certainly. Prometheus was born out of necessity at SoundCloud in 2012. They needed a monitoring system that could handle their microservices architecture. It was officially open-sourced in 2015 and became part of the Cloud Native Computing Foundation in 2016, alongside Kubernetes. Grafana, on the other hand, started as a fork of Kibana in 2013. Torkel Ødegaard, its creator, wanted to build a time series-aware dashboard and graph editor. It quickly gained popularity and became its own project in 2014.
Interesting. So both tools emerged around the same time, driven by the need for better monitoring and visualization in modern infrastructures. Now, let's break down what each tool does. Victor, could you explain the primary function of Prometheus?
Certainly. Prometheus is primarily a monitoring system and time series database. Its main job is to collect and store time series data, which are essentially metrics that change over time. For example, it might track CPU usage, memory consumption, or the number of HTTP requests a server receives.
I see. So, if I understand correctly, Prometheus is like a data collector and storage system for metrics. How does it actually gather this data?
Great question. Prometheus uses a pull model to collect data. This means it periodically scrapes metrics from configured targets. These targets expose their metrics at a specific HTTP endpoint, which Prometheus then reads. This model is quite different from traditional push-based systems and offers some unique advantages in terms of reliability and debuggability.
That's fascinating. Now, what about Grafana? How does it differ from Prometheus?
Grafana is primarily a data visualization platform. While Prometheus focuses on collecting and storing data, Grafana excels at presenting that data in visually appealing and informative ways. It can create dashboards with various types of graphs, charts, and alerts based on the data from multiple sources, not just Prometheus.
So, if I am understanding correctly, we could say that Prometheus is like the brain collecting and processing information, while Grafana is like the face, presenting that information in a way that's easy for humans to understand. Is that a fair analogy?
That's an excellent analogy, Sheila. It really captures the essence of their relationship. Prometheus gathers and processes the raw data, while Grafana takes that data and others to create visually stunning and informative dashboards.
Now that we understand the basics, let's dive a bit deeper. Can you explain how Prometheus stores data and how this differs from traditional databases?
Certainly. Prometheus uses a custom time series database to store its data. This is optimized for storing time series data efficiently and allows for fast querying. Unlike traditional relational databases, Prometheus's storage is designed to handle high write and read loads with minimal overhead. It stores data in a compressed format on disk and keeps recent data in memory for fast querying. This approach allows it to handle millions of samples per second on modest hardware.
That sounds incredibly efficient, but I'm curious, how does Grafana fit into this picture when it comes to data storage?
Great question. Unlike Prometheus, Grafana doesn't actually store the metric data itself. Instead, it acts as a visualization layer on top of various data sources. Grafana can connect to multiple types of databases and time series stores, including Prometheus, but also others like InfluxDB, Elasticsearch, and even traditional SQL databases. Grafana queries these data sources in real time to create its visualizations. This flexibility is one of Grafana's key strengths, as it allows users to bring together data from multiple sources into a single dashboard.
I see. So Grafana is more of a universal translator, taking data from various sources and turning it into visual information. Now, let's talk about some common misconceptions. What do people often get wrong about Prometheus and Grafana?
One common misconception is that Prometheus and Grafana are competing products. In reality, they're complementary tools that work very well together. Another misconception is that Grafana can only visualize Prometheus data, which isn't true. As we discussed, it can work with many data sources. For Prometheus, people sometimes think it's just for container monitoring because it's often used with Kubernetes. While it excels in that area, Prometheus can monitor any system that can expose metrics in the right format.
Those are important distinctions. Now, let's talk about some real-world applications. Can you give us an example of how these tools might be used together in a typical tech company?
Absolutely. Let's consider a web-based e-commerce company. They might use Prometheus to collect metrics from their web servers, databases, and application servers. This could include things like response times, error rates, CPU and memory usage, and business metrics like the number of orders processed. Grafana would then be used to create dashboards that visualize this data. For example, they might have a dashboard for their operations team showing system health, another for their development team showing application performance, and yet another for business stakeholders showing real-time sales data. The power of this combination is that it allows teams to quickly identify issues, track performance over time, and make data-driven decisions.
That's a great example, Victor. It really illustrates how these tools can be used across different parts of an organization. Now, as we're nearing the end of our time, let's address our quiz question. Victor, would you like to reveal the answer?
Certainly. The answer to our quiz question is that Grafana is primarily a data visualization platform, while Prometheus is primarily a monitoring system and time series database. As we discussed, Prometheus collects and stores the data, while Grafana excels at visualizing it.
Excellent. To summarize our main points, 1. Prometheus is a monitoring system and time series database, while Grafana is a data visualization platform. 2. Prometheus uses a pull model to collect metrics and has its own efficient storage system. 3. Grafana can visualize data from multiple sources, not just Prometheus. 4. These tools are complementary and often used together in real-world scenarios. 5. Both tools are flexible and can be used in various contexts, from system monitoring to business analytics. If we had more time, we could have delved deeper into topics like Prometheus's query language PromQL, Grafana's alerting capabilities, or how these tools integrate with cloud environments. Listeners, if you found this episode helpful, please subscribe to Technology Comparison's Crashcasts and leave us a rating. Your support helps us continue to bring you in-depth tech comparisons. Until next time, keep exploring and happy monitoring.